Dear students, today we will be discussing about the first module of MOS. In that itself, we are going to discuss about the first portion in this module. The first portion of this module is about the review of statics and that you have done in engineering mechanics. And it includes some of the portions which you have to rewind. That is, some of them are equilibrium conditions, free body diagram, centroid, moment of inertia, etc. Now, what are the equilibrium? I'm just refreshing you. You have to go through the engineering mechanics notes to get a total or a deep knowledge about all these concepts. Anyways, I'm just reviewing it. Okay, equilibrium conditions, you have thought of, or you have been known of three equilibrium conditions. That is, the total horizontal forces acting on a body, the summation of the horizontal forces acting on a body will be 0, the summation of vertical forces acting on a body will be 0, and the summation of the moment acting on a body will be 0. Now, next is the free body diagram. Free body diagram is a diagram which shows the relative magnitude and direction of all the forces coming on a body. And the example of the free body diagram is shown in the figure. Here you can see this is the real-time problem, and that is depicted as a free body diagram here. And we will be using free body diagram for the easy calculation of the forces. Now, next we are moving on to the main portion of MOS, or the first or the basic portion of strength of materials or mechanics of solid. The first term that you have to understand is about stress. Now, what is stress? You all know that there are various loads acting on a body. And these types of the types of loads can be dead load, it can be live load, or it can be some earthquake load or wind load, whatever the load may be. When a load is applied on a body, take this figure. In this figure, a load is applied on this body. And when a load is applied like this body offers a resistance against this load. And that resistance per unit area is termed as stress. Stress is force of resistance per unit area offered by the body against the deformation. Deformation in the sense, when you look at this diagram, you can see when a load is applied, you can see there is some deformation, there is change in the shape of this body, and that is termed as deformation. So, stress is the force of resistance which is offered per unit area by the body against the deformation. And I have told you that if load is the external force, load is an external force acting on the body, but this stress is something which is induced inside the body. And how will you calculate stress? Stress, the basic equation of stress is load divided by area. Stress is designated as or symbolized as sigma. Sigma is equal to P by A. The unit is, now how will you find out unit of stress? We know that the basic equation of stress is load by area. What is the unit of load? Unit of load is Newton. And what is the unit of area? That is mm square. So you will get the unit as Newton per mm square. Now, there are different types of stresses, and they are basically divided into two: normal stress and shear stress. In normal stress itself, there are two types: compressive stress, tensile stress. Okay. Now, what is tensile stress? The second figure shows tensile stress. Now, what do you understand from this figure? A load is applied in which the body is subjected to a tension. You can see this body is getting elongated. Such type of stress is termed as tensile stress. And what is compressive stress? This figure shows the compressive stress. When a load is applied in this direction, then this body is subjected to a compressive stress. Compressive stress in the sense it is pushed to inside, or it is getting bulged. Such type of stress is termed as compressive stress. Now, what is shear stress? Shear stress is shown in this last figure. You can see here a load is applied in these directions in which the body is neither elongated nor compressed, but it is having some tendency to tear off. This body will be having a tendency to tear off in the sense to remove off or to divide it into two parts. This portion, the top portion, will be having a tendency to move to this side, and this portion will be having a tendency to move this side. And these opposite tendencies cause this body to tear off, and such type of stress is termed as shear stress. Okay, fine. Now we are moving on to strain. Okay, I have told you that when a tensile stress is applied on a body, this body gets elongated. And when a compressive force is applied on a body, it gets compressed. That means there is some change. In all these cases, there is some change in the shape of the body, or there is change in the dimensions of the body. And strain is defined as the ratio of this change in dimension to the original dimension of the body. In this figure, you can see this is the original body. The length of the body is L and the breadth of the body is B. This is the cross section of the body. Okay, fine. This body is subjected to what type of stress is this? This is tensile stress, the forces which causes the body to get elongated. This is tensile stress. Okay, fine. This body is subjected to tensile stress. What happens to this body? This body has a tendency to get elongated, and that is shown. That elongated body is shown in this as this dotted diagram. Okay, fine. And when this body is elongated, you can see if L is the original change in original length of this body, now this length of body has changed to L plus delta L. Okay, fine. If B is the original width of the body, now the width has been reduced to B minus delta B. And this is termed as dimensional change. And the ratio of this dimensional change to original dimension, or delta L by L, will give you the strain. And what will be the unit of strain? The change in delta L is change in dimension. What is the unit of change in dimension? That will be meters, isn't it? Now, what will be the unit of dimension? Length, meter. So both of them are having same unit, and so what happens? The strain will not be having any unit. It will be dimensionless. Always remember that strain is not having any unit. Now, what are the types of strain? We have already discussed that there are different types of stresses such as tensile, compressive, shear, etc. So in strain also, basically depending upon the type of stress, there are different types of strain, such as if tensile stress is acting, then there will be tensile strain. If compressive stress is acting, there will be compressive strain based on the nature. Basically, there are two types of strain based upon the dimension, that is linear strain and lateral strain. Linear strain is change in dimension of the body in the direction of the load applied. This is the direction of the load applied, and this is the dimension which is parallel to the direction, or which is in the direction of the line of load application. That the change in dimension of this dimension, the change in this dimension is termed as linear strain, and the change in the dimension which is in the perpendicular direction to the line of action of the load. This is the line of action of the load, and perpendicular to this is this phase. The change in dimension of B is termed as lateral strain. So linear strain is the change in the dimension that occurs in the direction of the load, and lateral strain is the change in the dimension that occurs in the perpendicular direction of the load applied. Now, next we are moving on to stress-strain relationship. Stress-strain relationship is depicted by Hooke's law. Hooke's law states that within the elastic limit of a body, stress is directly proportional to strain. Stress is directly proportional to strain within the elastic limit. So sigma is directly proportional to epsilon, and sigma is equal to. So to remove this proportionality, we introduce a proportionality constant and let it be capital E. Then sigma is equal to E into phi, or E is equal to sigma by phi. And this constant is termed as Young's modulus of elasticity. So Young's modulus of elasticity is equal to stress divided by strain. Next, there are different elastic constant. One of them is Young's modulus or modulus of elasticity, which is specifically termed as linear stress by linear strain. Then next, there is another modulus of rigidity or shear modulus. It is, the equation is shear stress by shear strain. And another elastic constant is bulk modulus, which is direct stress by volumetric strain. Volumetric strain is similar to, the equation is similar. The equation for volumetric strain is change in volume to original volume. That is about elastic constants. Now we are moving on to the stress strain diagram of mild steel. This is the stress strain diagram of mild steel, and you will be you are frequently asked in the university to draw the stress strain diagram and explain about the various points of the stress strain diagram. In this figure, you can see there are various points such as proportionality limit, yield stress, ultimate stress, fracture stress, etc. Okay, fine. In this, you can see that from O to A, the stress is directly proportional. Okay, we have to first see that the y-axis shows the stress sigma and the x-axis shows the strain phi. And from this, you can see that up to A, the stress is directly proportional to strain, and that is why this is linear. So it's up from O to A, it is directly proportional. Stress is directly proportional to strain, and that point is termed as proportionality limit. Beyond this point, the strain is no longer proportional to stress. The next point comes is about the yield stress. Yield stress is the point about which the body starts to show deformation. If you are loading beyond yield stress, you can see that the load is getting, the body is getting deformed, even though getting deformed based upon the load applied. That means if you are applying tensile force on the body, then the body starts to elongate if you are loading the body beyond yield point. Next point is about the ultimate stress point. Ultimate stress point is the point about which, or it is the maximum stress that can be taken by a material. If we are talking about mild steel, then ultimate stress is the maximum stress or the limit up to which the body can take the stress. Maximum stress that can be taken by a body without getting fractured is termed as ultimate stress. The next point is the fracture point. Fracture point is the point about which the body starts to break or get fractured. Now, in the x-axis, you can see some various regions, that is linear region, perfectly plasticity or yielding region, strain hardening, and neck. That is, this is the region where stress is directly proportional to strain. So this is termed as linear region. Now here you can see that I have already told that beyond yield point, if you are loading the body starts to get deformed. And that even though you are not loading it, there are two types of yield point: upper yield point and lower yield point. Beyond upper yield point, if you are loading the body without a considerable increase in stress, there will be a large change in strain. Here you can see the strain is varying, isn't it? But the stress is remaining at the same portion, and that is termed as plasticity or yielding. Now, after this, you can see that from point C onwards, the body starts to regain some strength. Then the body starts to show some strength. It shows the strain based upon the stress applied on the body, and that portion is termed as strain hardening region. And after this ultimate, when the body reaches its maximum capacity, if it is loaded beyond this maximum capacity, the body starts to get or starts to take low decreased loads and reaches a point at which it get teared off or it get fractured off, breaks off. And that portion from D to E is termed as necking. Okay, if you're taking mild steel and then applying tensile force, if you're taking, think of a rubber band. If you are applying a tensile force on the rubber band, you can see that it is getting elongated, and if you are increasing it beyond a limit, you can see that at some point the area of the rubber decreases and it gets breaks off at that point. The same is applicable in this case also. When the mild steel is a tensile force is applied on the mild steel beyond its capacity, the cross-sectional area of the mild steel starts to decrease, and at some point it gets breaked off. This is all about the stress strain diagram of mild steel. Now we are moving on to a term termed as working stress. Working stress is the maximum stress to which a material can be stressed to work with its safety. That within safety, what is the without getting damage, what is the stress up to which a body can be loaded, and that stress is termed as working stress. Working stress is equal to ultimate stress divided by factor of safety, where ultimate stress is the maximum capacity of the body, and that's divided by the factor of safety. These are the basic concepts of which you have to keep in mind while going through the first module, and you have to get thorough with all these terms, that is stress, strain, modulus of elasticity, rigidity modulus, bulk modulus, now then working stress, factor of safety, etc. In the next video we will be discussing about how to solve the problems based on this. Thank you for